Alright, so what you are going to do is that you are going to clone this repository, which is my repository of a handwritten digit recognition. So we are just going to clone that. So now these are the files that we are going to start with, and so we are going to open MATLAB with it, and let's see if we can run it. Let's click on nn.m. Let's see if we can run it. Okay, so there's some problem. It says that it cannot find the MNIST chain thing, so we are going to find it, and so we are going to go for MNIST CSV, and download the change set and the test set for it. Alright. So this would take a while. So I think to myself, okay, maybe I would just skip this section of downloading the files. You guys should download that too. And so I think I'm just going to skip the download parts and come right back when we are completed. Okay. So everything has been downloaded. Let's check it out. Okay, so as you can see here, we have MNIST test.csv and MNIST train.csv. So that's our downloaded files. So we are actually going to move these files into the Git repository that we have just cloned. All right, so move that file to handwritten digit. Yeah, that's right. Okay. Now let's rerun our application, right? Let's rerun our code to see if it works. Okay, looks fine, looks good, nothing happens. Oh, so yeah, it says that it cannot find B2 stuff. So actually these are the initialized values for WNB. So what I'm going to do now is I'm going to use the generalization, which is weight initialization, to generate for us the weights and the biases. Alrighty. So as we can see now, we have B2, B3, B4 and W2, W3, W4. So those are the biases and weights respectively. Already, let's look. Yeah, let's take a look at our architecture. So our architecture is 7, 8, 4, 47, and 53 and 16 as I remember. So those are the number of nodes, and if you go to definition.m, you can see all of the parameters that we set here. The number of chain routes, the learning rate, the mini batch, the grade thing. So anyway, oh yeah, and also we also need to look at the activation function. I used Swiss function developed by Google Brain, I think, and it is the derivative of the Swiss function. All right, so I think we are ready. Let's run it. Yeah, this would take some time, and after I think I'll just stop talking here. You can skip to the end of this video. It will show that the accuracy probability is 0.9692. So that means it has 96.92% accuracy, which is arguably 97%. You can increase the accuracy by rerun the weight initialization, or maybe you can increase your number of training rounds, or maybe you can change your learning rate to be a little bit more smaller. But I think 0.00006 is just fine. So yeah. But roughly the model, if you run it a couple of times, it will oscillate between 27%. Yeah, it cannot go to 28%, but it's very unlikely to go under 96%.